All right, so we are going to learn today about area of a circle. So far, let's discuss what we've already learned. So far, we've already learned about circumference of a circle. And what did we learn about the circumference of a circle? What part of the circle is the circumference? Around, right? The perimeter, right? So we're going to say this is the circumference. The circumference is the distance of the outside of the circle, the perimeter. So if we were to flatten this line out, we were to say that's how long this line is. What did we discover about this line that cuts through half of the circle? What is that line called? That is called the diameter. And what do we discover about the relationship between diameter and circumference? We decided how many diameters are there in a circumference? 3, and then a little bit more. And so we said that this diameter fits 3 times around your circle to make it that magic number called circumference. 3 and a little bit more. So 3 and 1/7 more, right? 3 diameters in a circumference and 1/7 more. We call that number what? What do we call that number? 3.14. And what is its name? What did they call it? It has this perfect. It has a name for it. What is it? Pi. So we discovered that pi was the number that represents the number of times a diameter goes around the circumference. So 3.14 is called pi. The symbol that we use for it is what? The 16th letter of the Greek alphabet, right? That's our symbol pi. So when we do our formulas, we're going to use just C for circumference, our symbol of pi for 3.14, and what are we going to multiply it by to find circumference? We're going to multiply it by the diameter. So that was one formula for diameter. Then we said, wait a minute, what if they only give us half of the diameter? Or what's another name for this line? The radius. Half of the diameter is the radius. So we said, wait a minute, what is the formula if they only give us the radius? Our formula is going to be different. What do we have to do with it? Multiply it by 2 times your radius. That's going to give you diameter. 2 times radius, that's doubling your radius, will give you the diameter, and then pi. 2 times radius times pi is going to give us that formula for circumference. So we're good with that. I'm going to erase this part. And let's say, I'm going to actually erase this whole thing. Now, so we learned about all the parts of a circle. We learned about the distance around the circle. But now what we're going to do today is discover, and I can easily just tell you this is the formula to the area. But I don't want it that way. I want you to discover it. I want you to learn why is it working. The area. So the area is this green part. What is area measured in? Remember when we talked about area last week, that we were doing area of a trapezoid and area of a parallelogram. What is area measured in? In squared units, right? Area is measured in squares all the time. That means they want to know how many squares are inside this circle. Well, these are easy to count, right? These full ones. But what about this right here? This one's cut. Yes. This one is cut. So what do we have to do to count all these squares? That's hard to count. Area is always measured in squares, in square units, whether it be square centimeters, square inches, square feet, square yards, square meters, square miles. So our job is to find an easy way to count all these squares. Remember that when we were doing triangles, let's say we were doing triangles, we discovered that if we do a triangle right here, well, those squares were really hard to count too, right? But what did we discover? If we do our base times our height, if we do base times height, we get the area to a parallelogram, but we didn't want the area of a parallelogram. So what do we have to do to it? We'll divide it by 2. We didn't want that half. We only wanted this. So we would divide by 2. So we discovered that an easy way to count all these squares. We did the same thing with the trapezoid. What do we do with the trapezoid? Well, there's my 2 parallel lines, and these are my lines that aren't parallel. And what do we say the formula was? If this was base 1, this was base 2, what was a good formula for area of a trapezoid? Base 1 plus base 2, and then what do we multiply it? We multiplied it by the height, and then we divided by 2. Because if we don't divide it by 2, then we were getting a double trapezoid. A double trapezoid is your parallelogram. So all we did was say, well, this right here is my base to my parallelogram. This right here is my base to the parallelogram. Where does it come from? It comes from my base 2 plus my base 1, and then I multiplied it by the height. And then we had to divide by 2 to get rid of half of the trapezoid. Well, that's the same thing that we're going to do with the area of the circle. We're going to take the parts of the circle that we already know, and we're going to try to figure out what's the best, fastest, easiest way to find a formula that we can use to find the area of a circle, of any circle, right? Because formulas work with any size of that shape. So any size circle is going to give us that. So let me ask y'all something. I had y'all shade in part of your circle. Okay, everybody has a circle at their desk. I had you shaded in. I want to know that bottom part that we shaded in. So you all shaded in half of the circle, and you shaded in this part of the circumference, right? It is actually called a semicircle. Half of your circle is called a semicircle. So we outlined this circumference. So if we say that the formula to finding the circumference all the way around, and we're gonna use radius. We're gonna use radius. If the formula to find circumference all the way around is 2 times radius times pi, what if I only wanted half the semicircle? If I wanted the circumference to the semicircle, what should I do then? I don't want the full thing. I only want half of it. Divide by 2. Divide by 2. Does that make sense? So notice where my formula is coming from, and notice why we're dividing by 2. I want you to keep those 2 things in mind, because we're going to go to our circle and we're going to cut it up. Okay? I want you to go to a circle that you've already shaded. You shaded half of it. You outlined the semicircle. You outlined the part that's shaded. And then we folded it in half. We folded it in half again. And we folded it in half again. And I'm going to tell you, the more folds you have, like if I were to fold it up again, it would be a little bit clear. It would be better, but it's really hard to cut such small things. So let's just stick with eighths. We're cutting it in eighths. So I'm gonna push pause on my recording so that we can finish cutting it. I shouldn't record that. So this is what our circle looks like that we're gonna use. We shaded half of it. We outlined half of it. And then we folded it in half, folded it in half again, folded it in half again. And now we're gonna unfold it and we're gonna cut along all the folds, cut them all off. Am I recording? So now I'm going to take my pieces. I should have 8 pieces. If you cut it into 16, that works too. And I want you to build a parallelogram from this. You're going to take the shaded part and you're going to, the outline that we did from the circle is going to be the base of your parallelogram. And then the other pieces are going to fit in here like this. So at the end, you should have this really big parallelogram where these are your parallel lines and these are your parallel lines. Okay, of course it's not perfect, but can you see your parallelogram? All right, so I'm showing another tab right now. Not sure if it's recording or not, but those of you at home, you should be able to see my screen. Notice what we are doing, what we actually did is we took our circle, there's our radius, we took half of the circle, and notice how the circumference is a red line. If we cut it into pieces, we make the red line, half of the circumference, makes the base of the parallelogram. The other half is fit in here. So notice how all the pieces of the circle have made a parallelogram. Do we know how to find the area to a parallelogram? Yes, we do base times height. Well, where is our base coming from? Look at where, I'm going to go backwards. Look at where our base is coming from. The base of our parallelogram is coming from half of our circumference. So the base of our parallelogram is circumference divided by 2. Well, if they give us radius, then we do 2 times pi times radius, and then we divide it by 2. That's going to give us, if we cancel out our 2's, we end up with just pi times radius. So pi times radius is for the base of the parallelogram, pi times radius. But in order to find the area to the parallelogram, you need to do base. So we found the base, pi times radius, and now we have to find the height because it's base times height. How are we going to find the height? Well, where is the height from this parallelogram coming from? Well, it's showing us right here that the height is coming from R. Well, R is what? Let me go backwards. I'm going to go backwards. And I want you to notice where, okay, keep your eye on the R. R stands for what on our circle? R stands for radius. So the height of this parallelogram is coming from the radius. The height of our parallelogram is coming from the radius. So we're taking half of the circumference, which is pi times R, and then we're having to multiply it by the height, which is radius again. So we're having to say pi times radius is your base, times radius is your height. So in order to find the full area to this parallelogram, you would have to say pi times radius times radius. Or a better way to write that down is pi r squared. That's how you're going to see it on the formulas, pi r squared. So let's go back to our other part. our formula is area is equal to pi r squared. And I were to tell you this is 1, 2, 3, 4, 4.5, but I'll just say 4. This radius is 4. What are we going to do to find how many squares are inside this circle? Well, there's my formula. Area is equal to pi times radius times radius. So area is equal to, what am I going to put for pi? What number on my calculator am I going to put? 3.14. And I have to multiply it by radius. What's my radius? 4. And then I have to multiply it by radius again. What's my radius? 4. 4. R squared means this is the same as pi times radius times radius. It is not the same as radius times 2. That's just finding diameter. We don't want to do radius times 2. We want to do radius times radius. Radius times radius is going to give us r squared. So on your calculator, you would do 3.14 times radius, and you would end up with 50.24. 50.24. If I were to say these were centimeters, then 50.24 what? 50.24 centimeters squared. That means that there are 50 and a little bit more of a square centimeter. These little blue squares that I counted are 1 centimeter by 1 centimeter. And if you were to sit here and count them all, you would count, and then you would add up all of these, you would add up all these little ones, and you would end up with 50 and a little bit more of another square. 50 squares. That's how you put this to use. Then you could have where they're giving you your circle, and then they tell you that the diameter is equal to 12. They tell you that the diameter is equal to 12. Well, all we found was the area of a circle was pi times radius times radius. They never gave us a formula using diameter. Well, there is not one. We don't use diameter for area. When we're doing circumference, there's a formula for diameter, there's a formula for radius. But when you're doing area, there's only a formula to using radius. So can we still do it if they're just giving us diameter? Yes. What do we have to do to turn diameter into radius? Cut it in half, right? How do we cut it in half? Divided by 2. What is 12 divided by 2? 6. So I know that if my diameter is 12, then my radius is 6. Now I can put my formula to work. Area is equal to pi. I'm going to change to 3.14. Radius is going to be what? 6 times radius is going to be what? 6. So what happens when you do pi times 6 times 6? Say it loud, please. 113.04. And what if I said these were yards? These were represented yards. What am I going to do? Yards squared. Yards squared. 113.04 yards squared. So that is how you use the formula to the area of a circle. Pi r squared means pi times radius times radius.